Welcome guys. In this lesson we will talk about the RC and RL filter theories. We've covered the circuits of RC and RL. We've done some calculations and we looked at the graphs and also the phasor diagrams. And before we move on to RLC circuits, where we mix everything, there's one more thing that we have to learn, which is the filter theory. So you may ask, okay, what's the point of having a resistor and capacitor, or resistor and inductor? Okay, it's cool to calculate and see what's going on, but like, what's the end goal here, right? What is the end goal? Well, the whole point of making the RC and RL is so that we can make the filters. And what we mean by filters, you know what the filter do? They strain out, they filter out unwanted stuff, right? That's exactly what's going to happen. But we don't have to overcomplicate this. All we need to know is a solid understanding of opens and shorts. What happens in a circuit when there's open and short, right? And second, if you guys know the relationship between the frequencies and frequency, and then the reactance of the capacitor or reactance of the inductance, and see what that happens, and then you're good to go. All right? So, first thing that you need to know is opens and shorts. Second, you need to know is the relationship of frequency and XL or XC. And let's write it down. So if the frequency goes up, the XC will go down. If the frequency, goes down, then XC will go up because the inverse, right? 1 over 2 pi FC is the formula for XC, and 2 pi FL is the formula for XL. So it has a direct relationship. XL, if you decrease the frequency, XL will also decrease. It has a direct relationship. All right, so let's start with RC. Let's start with RC circuit. We have a power supply, we have a capacitor, and I don't really need to know about the value of these, all right? And the point of the filter is, how can we get a maximum voltage output? Okay, maximum voltage output or current output, doesn't matter, right? How can we get the maximum voltage output? The only thing that we can vary in this case is the capacitor. Okay, we're going to vary the capacitor because resistor here in this example, it's fixed. Okay, it's in the circuit that we can't really do anything about it. And also as a capacitor, we're not going to change that actual capacitor, but what we're going to do is we can change the capacitive reactance, right, by varying the frequency, correct? These two cannot be replaced, but we can vary the values of it by varying the frequency because it's AC. Under what condition, when you vary the frequency, do you think we'll get the maximum output? What I'm trying to really ask is, let's try to make this into either open or short condition to get a maximum voltage output. What do you think? Well, let's see. If I make this an open circuit by lowering the frequency, when you lower the frequency, my XC, which is a reactance, resistance, right? Reactance, opposite to current flow, is going to shoot up high. So which means it's a very high opposition, so it's going to act like it's open. When that happens, guys, what do you think my voltage output will be? Imagine this was 10 volts, right? I got my multimeter, I'm measuring. What do you think I'm going to measure? Well, I'm going to be measuring 10 volts right there, 10 volts right there, and at this point, 10 volts, correct? But moment I go across the break, what do you think I'm going to measure? That's right, I'm going to measure 0 volts because there is a break. Before the break, I'm going to read the full voltage. But after the break, I'm going to read rest of them is going to be all 0, which means my voltage output is going to be minimum, nothing, 0. So that's not going to work because our intention, our goal is to get a max voltage output. That's our goal, right? Well, we lower the frequency, and that didn't work. Well, let's see, let's go the other way. Let's increase the frequency, see what happens. If we increase the frequency, now what are we doing to our XC? We are going the opposite. XC, my reactance is gonna come down so much, right? We're gonna be increasing to like 10 megahertz, let's just say, and my XC is gonna go down almost to nothing. When I say almost to nothing, let's just say it's 1 ohm, for argument's sake. Is that much of a resistance? Is there much of an opposition? No, it's not. So it's gonna act like a short. Even though the capacitor is there, it's going to act like short because the opposition to current flow is so small. It's only 1 ohm or 2 ohm, whatever the number is, but it's negligible. So then let's see what happens to the circuit. Okay, let's go again. So what am I going to read if I have a multimeter there? Oh yeah, this is 0, right? And this is 10. I'm providing that way. So 10 volts, 10 volts, 10 volts, 10 volts. 10 volts, 10 volts, 10 volts. Hey, I'm providing, it's a full, complete circuit. It's not broken circuit. I'm providing 10 volts to the resistor. This looks like a single resistor circuit, right? So I'm gonna read, obviously after the resistor, I have to drop all the voltage. So it'll be 0 down there and 10 before the resistor. So I'm gonna read a maximum voltage up. I'm gonna almost read the full source voltage. I achieved max voltage output by increasing the frequency, therefore lowering my reactance capacitance. So the name of this filter is high pass. Why is that? Well, the way I like to explain is pass means max voltage. This is my own interpretation, okay? Pass means I'm passing out maximum voltage, all right? And high means at what frequency? At what frequency? At high frequency, I'm passing maximum voltage. If it's low frequency, I'm not gonna pass any voltage. It's gonna be very low. It's gonna be almost 0. So that's not going to work. So the name of this filter would be high pass. At high frequency, I get maximum voltage. Let's look at the other example. Next up, I'm going to flip the location of resistor and a capacitor and let's see what happens. Before I had a capacitor first, I'm going to have a resistor first, and here is my V out. Okay, and then after my resistor, there is my capacitor. Okay, so these are my measuring points. Obviously, this is going to be 0 volts. And let's just pretend this is 10 volts. Let's see what happens. Now I want to measure across the capacitor. Okay, under what condition, when I'm varying the frequency, because I can't touch these values, right? But I can vary the reactance by altering the frequency. So under what condition, guys, can we read a maximum voltage output here? Because that's our goal. Let's increase. Last time when we increased the frequency, it kind of worked. So let's see. When we increase the frequency, my XC goes down, correct? When my XC goes down so low, it is going to act like a short circuit. Right? It's going to neglect the value. It's almost like it's having a straight wire. Let's draw this. It's almost like having a single resistor circuit. What is going to be my output between these two? Well, I drop everything. right, across this resistor. It's going to be 10 volts, so I'll have nothing left. Oh, that's not going to work. Okay, well then let's go the other way. Let's drop the frequency all the way down, super low, 10 or 20 or 100, and that in turn is going to increase our reactance. When we increase our reactance infinitely, then what are we doing to this capacitor? It is now going to act like it's open. The opposition to current is so high. And what do you think that's going to do? What do you think that's going to do? Exactly same as this guy right there. So if I was to do this, I'm reading 10 volts, right? I'm measuring the voltage output of the power supply. Still 10 volts, still 10 volts, still 10 volts. Everywhere before the break is all 10 volts. However, after the break, what am I reading? 0, 0, 0, 0, 0, 0, 0, 0, 0, right? 10, 10, 10, 10, because here I'm reading 0. That didn't change. But everywhere else before the break is all 10, 10, 10, 10, 10, 10. 0, because we're reading the potential difference. 10 volts here, 0 volt, 10 minus 0, 0. Oh, sorry, 10. 10. 0, 0, 0, 0. Here, and now I'm going to read 10 volts. Okay, so how did we achieve a maximum voltage output in this case? By lowering the frequency. When we lower the frequency, our reactance for the capacitor went up, ended up opening the circuit. Therefore, I was able to read a maximum voltage output. So if you can guess what the name of the filter is, it's a low pass. Pass again means max voltage output. When it's low frequency. When it's low frequency, now I can get a maximum voltage output. We switch the position, and now this becomes a low pass. What it really means, guys, is that it's only letting the low frequency to come in, right? And filtering out all the high frequencies. It means it's filtering out all, I don't want any high frequencies, and it's just dumping it. That's what it means, okay? So if you were to use, I don't know if you guys use the equalizer on your phone or any other audio devices, there is a treble for focusing on the higher tones. There is a mid and there is a bass. A low pass will be a bass. It will only let the bass, like the low tones, to come through, and then it's filtering out all the high frequency. If it had a female singer, it's going to fade away. It's going to minimize the volume, the decibel, minimize the volume of the high frequency to almost nothing, and it's going to boost up the low frequency, which is like a low voice like mine, or like the bass guitar or drum kick or something like that. And treble, on the other hand, that's the good example of a high pass. So it's filtering out the bass and only letting the high female singer voice to come through. That's why we use low pass and high pass. So that was the example of RC. So let's look at RL. Guys, it's exactly the same, right? Here we have RL circuit. Let's see what happens here. Again, what are we trying to do? Oh, I forgot to draw UV out. Our point is to get a maximum voltage output. Okay, we want to filter out. So I want to get a maximum voltage output or maximum current. So what do we do? Let's see by increasing the frequency. But when we increase the frequency, we're going to increase our reactance inductance. And what that does is we're increasing the opposition to current flow, which means we're opening. It's going to act like an open circuit as the resistance is so high, right? So what happens here? It is going to look like it's open. So if it was 10 volts that I'm providing, anything after, obviously, after the voltage source, the power supply, before the break is going to read the source voltage. And here is 0 volts. That doesn't change. That's still 0 volts, still 0 volts. Anything along these lines is going to read the source voltage. Anything after that is going to be all zeros. Do you guys see that? Anything all there is going to be 0. Anything before the break is going to be the source voltage, which means here, if I was to read the difference, potential difference between 0 to 0, 0 to 0, it is going to be a 0 volts. Is it maximum? Absolutely not. It is minimum, and that's not what we want. So then we go the other way by decreasing the frequency, and that is going to decrease our XL reactance. When we decrease the resistance or the opposition, then our ohm's going to be super small, 1 ohm, 2 ohms. It's almost like a wire itself resistance. So then it's going to look like a straight line, right? It's going to act like it's not even there. When that happens again, anything before the resistor is going to read, source voltage. I'm so used to writing the 10 volts. And anything after our only resistor is going to be 0 volts. So am I going to read the maximum, which is a source voltage, or the minimum, which is 0 volts? Definitely 0 volts right there, source voltage. I'm going to read a maximum voltage right there. So what do you think our filter is? What are we filtering out? We're filtering out the high frequencies, right? We're filtering out high frequencies. We can get the maximum voltage output during when we are at low frequency. We can get the maximum voltage output when we are at low frequency. So this circuit is a low pass filter, okay? Filtering out the high frequencies and only allowing the low frequency to achieve a max voltage and current output, okay? Let's swap these around and see what happens next. I flipped those two components around. Now we're measuring across the inductor instead of the resistor, like we did last time. Let's see what happens. First, because we picked the low frequency last time, let's see what happens if we actually decrease the frequency. Yes, our opposites to current flow are in reactance. Resistance is down to almost nothing, which means, oh, I should have corrected this too. One sec. I'm back with a new schematics here. So we were just talking about lowering the frequency by lowering the XL. And if it's low XL, low resistance, we're doing this. It's acting like short. So anything before the resistor is source voltage. However, anything after is 0. So if I'm reading 0 here, because everything after here is 0, and if this is 0, what's the difference? 0, so I have no output. And that's not the goal, right? We want to get a pass. We want to get a pass, maximum voltage output. How can we do that? By increasing the frequency this time. Now increase the reactance. If we increase the reactance, the circuit is now going to act like an open circuit. So again, anything before the break is going to read the source voltage. Anything after the break is going to read a 0 voltage. What is my difference between the two? Yes, it is the VS, which is the max output. So under what condition did we get the maximum voltage output? Was it low or was it high? Yes, it was high. So this makes it a high pass. It's filtering out all the low frequencies. If it's low frequencies, I get minimum, 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 minimum output until I hit certain high frequency, goes up and I get the maximum voltage output and current. That's all there is to it. If you have the good understanding of opens and shorts, and then the relationship between the frequency and all of the XC and XL, your filter theory becomes super easy. It's not hard, but the obstacle is having a solid, strong foundation in opens and shorts. Can you guys guess what those filters are? I'll give you guys some time to figure out, and we'll go over the answers together. Let's go. Okay. Let's go over the answers together. Let's look at the situation. How do we get the maximum voltage output? Well, we want to get the maximum voltage output by opening it, right? We want to open this capacitor. How can we open it? Capacitor says, I want to increase the reactance by lowering the frequency. Low frequency, low pass. How about the next one? How do we do this? Same idea, we want to open it. How do we open it? By increasing the frequency. So that's a high pass. You guys doing well? Let's go to the third one. How can we get the maximum voltage output? By shorting it. How do we short it? By lowering the reactance by having a low frequency. So it's a low pass filter. The next one, how can we get the maximum voltage output? Same idea. We want to short the capacitor. How do we short the capacitor? By having a high frequency. High frequency, low reactance. So high pass. How was that? Not so bad, right? I hope you guys got it all. Next, I'll show you, it's a graph. You know what really happens during a low pass and high pass, what the graph really looks like. I'll quickly have that up, and we'll close out the lesson. Thank you. Here they are, guys.